Hello folks, welcome all of you to Global Coding Cohort. In the previous session, we learned about function, analysis function, then class, member functions. I hope all of you understood those concepts yesterday. If there are any new viewers, please watch all the previous videos. You can go to my channel under live section. You can see all the saved copies of live streams. Today, let's start with scope of variable. Both visual and audio is clear. I hope it there is no I hope there is no issue in audio and visuals. If there is any issue, please let me know in the comments. To explain about it, let's take an example. Now let's assign 5 to A. And now I am adding 1 to A and printing it. Now the value of A became 6. Now let's see another sample function equal to A plus 1 return A. Sorry, we have to pass argument over here. We will return our we will pass our existing a equal to 6 to this function, and we got 7 as output. Now let's check the value present in A. It is still 6. Why? We passed this variable to this function called sample, and there we added 1 to A and stored the result also in A. Returned A, isn't it? But why is this changed? We assigned the value A equal to A plus 1. Why this change is not reflected in this A? So there is where scope of variable plays. The scope of the variable, this particular A, is getting limited within this function, and this A scope is present outside this function. Got it? All are A, but the A present within this function has its scope within this function itself. Got it? That's why the A that we have outside of this function remains 6. Understood? Now let's see the same concept to help of class. Sharpen class. Now we created a class with a function, class method, sample method. And inside that, we are getting a variable in A, adding on with it, and storing that in A, and returning A. Note that we also have a variable here, A assigned with 1. But self.a means throughout this is accessible. This is a variable of this, a variable which belongs to this class. Got it? This is just a public modifier. Anyone can access this variable, but throughout this class, we can also access this. So now let's see what happens here. The method, I'll pass a value 1. That's what we get. We got 2. Then we have a variable right here. That is this A. Let's display it. We still have that as 1 because the A present in this method has a scope. It's getting its scope limited within this method itself. Got it? But if this A has to update, then probably we have to put self.a. Only then change will be updated. So you check it once again. Now you can see the value that we passed over there got added and stored it in self.a, and we can see its result here. This value got changed to 2. Previously it was 1, isn't it? Previously here it was 2, but now it is 1. Why? Because a plus 1 is added and stored in self.a, not in a. That's why, but we are returning just a. That's why we got 1 over here. Understood? Understood the difference? Let's make the code back to its original form. Next, yesterday we missed this. That's why I told about this concept today. Anything else? Okay, one more thing. Uh, Now we learn scope of variable. Now I will show you another way, another one thing, some other concept. Yesterday we saw for this concept, I don't know what name to give. Okay, let's simply have it something like this. Article. Let's simply have this something like this. You would have seen this in many places. I'll tell you the meaning that it makes. Okay. Now let's create a definition or a method. For example, yesterday we saw something like this, a equal to, okay, let's have something like this. Return a plus, return a, return a, that will do. We pass something over here. It will return that, is it? Not okay, no problem. Let's perform an operation also. It got added. Now I'll show you another one thing. That means, okay, it's no problem. No need to add, so that will be clear. No problem. Okay. Now let's add star arc, arcs. Arcs will be considered as a variable. Okay. Here, let's see what happens. If we pass one to it, one is returned, but arcs has nothing. That's why it has shown something like this. What if here we have, yesterday we saw, okay, let me show you that a return a. If I try to pass one, it will work. But if I try to pass one more variable, then it will return error, is it? But here, as we passed star args, the balance values will be taken by this variable args. Sorry, we didn't execute that args. Got it? So now you can see this 2 has gone into args and a remains same 1. Why we get it in tuple means we are returning 2 variables. That's why we get that output inside the tuple. Okay. Okay, no problem. For your understanding, for this instance, let me just return only args and print DA. Okay. Okay, so no problem. Both scenarios will be addressed. Got it? Or it's no problem. Let's run the same. Run it also. I have not made any materials already. Right now, I'm teaching you from the knowledge that I have in my mind. That's why I'm changing continuously to make it in a way that is very easy for you to understand without any overhead. That's why I'm changing the examples continuously. Yeah, if I am repeating it this same concept tomorrow, I'll be taking some other examples maybe. Okay. I do not have a, I don't keep any notes prepared already. So the way I teach and the examples that I use to teach may change dynamically over time. Okay. So it will not, it will take n number of variables also. Okay. Let me give string, and that will also be taken into args. But the first value that we give over here will be taken by the variable that we give at first. Got it? If we give a tuple or list of values here, then that will be given to directly A. Okay. This will be considered as a single value as list and will be assigned to A itself. Right. Now I will show you what is Cohort. Sample A. Why star star means key value. That's why. And A. Here this function will throw an error when we give something like this. A equal to 1, B equal to 10. This will throw an error because we have not mentioned any variable as B to receive the value that we give as B. But at the same time, this works. We'll accept it. But even if we give, let's try with 1. Works as nothing. 1, 2. When we give just 2, this will return error. But when we give something like this, A equal to 1, B equal to 2, this will accept. That is the difference between star arcs and star star quarks. Got it? Understand the difference? Take note along with me so that you can efficiently remind it. Write it in a way that you understand so that it will be easy for you when you revise later. Understood? Okay, what else? Did I miss anything? Okay, no problem. Even if we miss something, we will say it in the upcoming sessions. Okay? No worries about that. Now let's see. Learn inheritance. Yesterday we saw how to create a basic class, the functions, and we saw different types of classes modifiers as well. Today let's see inheritance. Like the like the word mentions, it also gives the same meaning and working principle in this programming language also. Okay. Inheritance means there will be some parent-child relationship, is it? Parent, child, grandpa, or etc. etc. Is it? So here we have five types of inheritance. Single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. Understood? Note this. I hope you noted it. Take notes along with me. Okay. Single inheritance. Assume that there is a parent. Single. Okay. There is a parent class. Parent. This is parent. Then this there will be a child. There will be only one child. This child gets derived from parent. Okay. Child gets derived from parent. So this is so it will have only one child. So this is called single inheritance. Take notes along with me. I hope all of you have taken these pictures. Now let's move to the next concept. Multiple inheritance. And now onwards, just for an example, for understanding, I named it as parent. It's actually base class and derived class. Okay, base class and derived class. In multiple inheritance, there will be more than one. There can be any number of, but more than one base class will be there. Okay, you can have 2, 3, 4, 5, n number based on your requirement. You will have and a single child. Means this derived class will be derived from both these two base classes. These two base classes. This child class or derived class is derived from these two base classes. Noted it? Let's move ahead to next concept. Now let's see multi-level. Multi-level means base 1 will be a child to it. This is child 1 of base 1. This is, let's consider this as base 2 because this is act as a parent to another child class, derived, derived class. Okay. This is child 1 of base 2. Understood? For understanding, when we have this when we have this type of chain, means three classes interlinked together, we can consider this as something like this: new kid, dad, or parent. Generally, let's have it as parent, grandparents. Something like this relation. The relationship has some relationship like this. This will happen because parent got derived from grandparent and kid got derived from parent. They are interlinked. Understood? This type of relationship. Interlinked. Step, step, step. Different levels of relation. That's why it's called, that's why it is called multi-level inheritance. So, single, multiple, multi-level, isn't it? Now let's say hierarchical. Okay. Now assume this as a parent, and this parent has two kids. Derived classes. One and two. So one parent and two child classes or derived classes. This type of inheritance is called hierarchical inheritance. Means one parent and multiple derived classes. Got it? I hope all of you noted it down. Now let's see hybrid inheritance. Hybrid. Deriving from these two derived classes. And this is multiple, right? Multiple plus, and just again one more thing, derive one more child. There can be a combination of anything, hybrid, sorry, multiple plus multi-level or single plus multiple. Any type of, sometimes some type of combinations of the first four will be there. Combination of any two or three or four of the first four inheritance, first four types of inheritance. That may be either single plus multiple, or multiple plus multi-level, or multi-level plus single, or single plus hierarchical. The combination will be there, okay? And that is a combination of multiple types of different types of inheritance is called hybrid. Here we can see a hierarchical relation. Here we can see multiple relation. Here we see a single relation. Even if we extend one more to this, here we can see a multi-level relation. So this is called hybrid inheritance. Got it? Now let's understand each type with example. Uh, why should we go for this concept is just assume mm, okay, assume that some operative member has already developed a class to do addition operation. Just assume something like this scenario, and here we have it, A, B, return A plus B. This class will then add equal to run in standalone mode also. Okay. Now if we run this, sorry, then add dot add of, if we pass two variables on comma 1, it will return 2. Simply mention is a normal, okay, normal inheritance base class. Why we are going to consider this as base class means now your team leader has assigned you a task to extend its functionality to retain the same function to retain the functionality that this particular class also does. Also, he wants you to create one more functionality without losing this particular functionality of this class. So what you do means mm, now you will create class add sub of with add inside it. You are by writing add over here, by writing this class name over here, you are deriving the properties, you are deriving the behavior, all the functionalities of add to this new add sub. Got it? You are extending its features. This is consider this as an already developed feature. You are extending, you are upgrading the existing feature. So that whenever you call this new class, we should be able to access this add function also. Got it? When you create a separate subclass, for a separate class for subtraction, then there you cannot access the function for a, sorry, add. Okay. So what we do is sub call a, sorry, a b. return a minus b. Now let's see, add sub equal to add sub dot, can add sub dot. You can press tab over here after writing dot. First tab, you can see both the functions, add and sub over here. But which class did you call? We just called only add sub. But as you inherited add sub from add in this line, you are able to access the method that is present in add also through this new add sub class. Got it? So you need not have to touch this part at all when you extend the functionality of any feature. So when you extend the existing functionality of any feature, when you upgrade some feature, you need not touch that class itself. You can just inherit that class by placing something like this, and you can extend its feature or functionalities. Got it? That is the situation where you need to go and use this inheritance. So there will be different type of scenario. At different scenarios, different types of inheritance will be implemented. So now let's see an example, something like this. Sorry, when we call add, we got its output. Sub 1, we got 0. Understood? This is derived class. Now let's see next type of inheritance called multiple inheritance. Now let's assume two of your team members have already developed class one. There are two members. They have already developed one developed class for add and another developed. Assume the situation to be something like this. Okay. Let's we need not to rewrite this class again. We will use it the same base class add. Okay. We'll just write sub over here. Sub class 2. Just base class 1 because already it has only one base class. Okay. So you will not get confused. Now this is base class 2. In this case, now you are one, you are third one in your team. Okay, you are given a task. Okay, right. Previously that was okay, but now suddenly some requirement came for your project. So that to avoid overhead, your team leader has asked you to combine to retain that those functionality of the class without touching it, but you want both functionality by accessing a single object itself. This is a task assigned to you. So in that scenario, you will write a derived class something like this. So what will you do means, okay, already we have add subdivision. Now let's give a new name. Okay, no problem. Add sub multiple. Okay, this is not a good standard. Good practice. We should not use underscore for any class. Use that only. We can use underscore only with normal method name or variable name. Okay. Instead, you can start all the letters with caps letter. Sorry, each word with caps. You can start each word with caps letter. Got it? We need not give multiple. Okay, no problem. We are continually executing, right? No problem. Okay. Uh, let's have the same name. But after we execute this cell, we should not expect to get this code executed. Okay. After this code is the cell is executed, this new code will be present in the class name add sub. Okay. Don't get confused. So here we will be called add and sub. Now when you call this, here you can see you can get both that add and sub variable over there. The variables are different. Okay. Here we have given okay. I'm executing this continually. So now this variable got overwritten by this new add sub. Okay. So there you need not need to have any confusion over there. Okay, no problem. Uh, you understood, right? Continuously. Okay, just see to make sure the add and sub that we got over here is not from the previous temp add sub variable. You can access add and sub over here. Come on. Come on. What is now? Let's see multi-level inheritance. And to see multi-level inheritance, let's use the code. Let's use this particular code. Okay. Things will be confused, right? Okay, no problem. Let's keep it as single. Multiple. Why I avoided the giving multiple means soon we will have a situation to see multiply. That's why multiple and multiply should not be. I thought at that time I thought that multiple and multiply should not be confused. But now I seeing this scenario, I thought that is better than that scenario. That's why now I add single multiple like this works to this class. for multi-level, let's use the class. This is single, right? This is single. To the single, if we add one more box, okay, let me draw it down, clarify it clearly. This is single inheritance. If we add one more child to it, then this is multi-level. Understood? That's why we are using the derived class of single inheritance here. Understood? So what is that name? Add sub single. Got it? Add sub single. Now for multi child derived class, class add sub. Okay, add. Let's have this class as add sub mul. Okay, may not be multiply. If you give, you will get confused only if you give multiply and multiple seeing both classes. There are chances for you to get confused. Okay, now add sub single. Mul A, comma B. Return A into B. Then add sub null equal to add sub null of, okay, column. Then in this particular variable, you can access add, multiply, and subtraction. All those are listed. Let's try. Now one. Sub, we got it. Let's change the variable to 4. Got it. What next? Hierarchical. Uh, what example shall we use? Okay, now I get an idea. In this multiple, we could have done something like this. We could have any number of base classes. That means add, sub, mul, and division. And we could have made this probably as a math class. So that base math class will have addition, subtraction, multiplication, and division. There is also that is also an example of multiple. Okay, okay. Well, when I explained, I didn't get this idea. Get this idea. As I got it now, I'm telling it. Add, sub, multiplication, division can be brought down in a single class called math, and that can be taken as an example of multiple inheritance. Okay. Now hierarchical. Hierarchical. Okay, no problem. Let's assume a class called math, and it has different functionalities like add, sub, comma b. Null. MI type. Can they take notes along with me? Just don't sit simply and watch video. Just take notes along with me, okay? Okay. Now we have some. Now we have a base class called math, and we assume that we have different. mm, okay, this addition, subtraction, multiplication, division almost comes in many problems, isn't? Many math problems, isn't? So let's consider problem type 1. Derive class 1. Class problem type 1. And we insert from this parent math so that we can utilize its basic math functions from here. Got it? Let's have some task over here. Task A, comma B. We will do something like this. Sorry. Dot add of A, comma B plus sorry dot sub of A, comma B. Okay. Now let's derive another one class. Derived class to problem number. Sorry, problem type 2. Then inheriting from the same base class. What is the meaning of hierarchical? We have one base class and many child bits derived from the same base class. That is what. For example, I am creating some funny scenarios like this. In real thing, we'll get tasks that sets for this type of inheritance. Got it? Task of A, comma B return null of A, comma B minus self dot day of A, comma B. Now let's create object for both of these. Problem prob1 equal to problem type 1, then object for second equal to problem type 2 or then passing. I'm going to pass value to both of them. Dot uh, task of 1 comma 1. Okay. Then to dot task of 1 comma 2. Got it? Hybrid, any combination. Just take it as an assignment. You can uh, You yourself can mix any type of inheritance and make a hybrid one. Got it? So understood? Go through this portion which we learned today. And that's it for today, folks. See you tomorrow. Bye bye.